Physics, Newton's laws, P22F describe examples of the forces acting on an isolated solid object or system. This is mostly the analysis done where we have something called terminal velocity, and this a lot of times it applies to objects that are falling, the objects that are under the influence of gravity. For example, let's say free falling, the skydivers. Now, when a skydiver is jumping out of the plane, one thing never changes during its motion, that is the force that's pulling the object or is pushing the object down, that person down, the weight. So the force pushing down, the Earth's pull doesn't change, stays the same. So that means because the mass of the object, the mass of this person, if he has 60 kilograms when he jumps off the plane, he's going to have 60 kilograms when he reaches the ground. And the force of gravity doesn't change, barely changes for this distance of a few kilometers that you need for the jump. So the weight always stays the same. Now, terminal velocity is the situation when there are balanced forces, when forces are equal, when there is no acceleration. Terminal velocity, the speed, stays the same. That's a steady speed motion. Now, for example, when a skydiver is jumping from a plane, so the object is released from rest, that means he's jumping from the plane. There is no air drag force yet because he's just jumping from the plane. So there is only the force of gravity pulling the object down, or the weight of the object. Now, when after a certain amount of time, as you're falling through the air drag force increases because you're hitting air particles. That means there will be this force, the yellow force, that keeps increasing. So as the object speeds up, this yellow force gets bigger and bigger. We can see that the blue arrow doesn't change, so the weight of an object is the same. Now, after a certain amount of time, as you're falling through the air, you're getting faster and faster, but at this moment, the air drag force will be so strong that it will practically equal the force of gravity. So that means the yellow arrow will equal the blue arrow. But the object is already moving, so the object, it's not possible for the object to stop. What is possible is for this object to move from this point on up to the point when the parachute opens. The object falls at something called the terminal velocity, because at this moment, let's say the object of the skydiver, the speed of the skydiver now is, I don't know, let's say 100 kilometers per hour. Well, the skydiver from this moment on, up to this moment, the skydiver went from 0, 5, 10, 15, 20, 30, 40, 50, 60 kilometers per hour, 70 kilometers per hour, 80 kilometers per hour, because the blue arrow, the air drag, was smaller. 90 kilometers per hour. When the skydiver reaches 100 kilometers per hour, these blue and yellow arrows equal, they will be the same. And then that's the situation where you have balanced forces. When the forces are equal, no acceleration, so it's not going to be able to go faster. The terminal velocity, it's reached already. The speed stays the same. That is a steady speed motion. From this moment on, these two arrows stays the same up to the point where it opens the parachute. So we see that the blue arrows, the force pushing down, the Earth's pull doesn't change, always stays the same. The only thing that changes is the yellow arrow, the air drag. So air drag friction is smaller to begin with. So at the beginning it's smaller because you don't have speed and because you're not moving through the air yet. And increases because you're moving faster. That means you're hitting more air particles. That means there'll be more friction, more drag from the air particles, until it balances the weight of the person. When the force of drag equals the force of gravity, the air friction equals the force of gravity, we reach the situation when there is terminal velocity. The airplane, for example, now the airplane is not falling because there are some other forces that keeping it in air, like thrust and lift. But we see here when the lift, this is at takeoff, the lift is larger than the weight, so the airplane is going faster and faster. From the ground speed, which is 0, balanced forces, it's going to go faster and faster, unbalanced forces, and at a certain amount of time, it will, after a few minutes, it will reach a cruising steady speed. That means there will be no acceleration because all of these, so here the forces are not balanced, but because all of these forces will be balanced, so practically the airplane will reach terminal velocity because the thrust of the airplane will equal the drag. The airplane will not be able to go faster, even though it might try to push, it might try to push up the thrust, the throttle, but it reached the maximum speed it can reach.